Alright, so I purposely put the graphs of sine, cosine, and tan over here just so that if you need a reference point, you can go back to it, because this lesson's all about transformations, and we have to transform from these original graphs. So just for a reference, they're there for you guys. Before we get into it though, let's just review some of the transformation parameters. What does A stand for? Joseph, do you remember? What kind of stretch? Vertical, perfect. Okay, Booker, what does B stand for, besides Booker?
Horizontal.
Good, we have a horizontal stretch. What do we have to remember about the horizontal stretch?
Inverse.
No?
Well, like 1/3.
The reciprocal?
No, yeah, reciprocal.
Okay, good. Jackson, what does the C tell us? Call a friend.
Right or left?
Right or left, so it's a horizontal translation. And Jared, what's D?
Vertical translation.
Vertical translation, up or down. Perfect. So we can apply transformations to sine, we can apply transformations to the graph of cosine, and we can also apply transformations to the graph of tan. Okay, in this lesson, we're going to strictly focus on vertical and horizontal stretches. So we're not going to look at the horizontal or vertical translations today, just the stretches. So let's take a look at a few examples and we'll discuss what transformations are occurring. So in comparison to the graph of y equals sine x, which is over here for us, okay, based on the equation alone, what does the 2 tell us? Stan? Yeah.
Stretch.
By how much?
2.
Good, we have a vertical stretch of 2. Okay, Chris, what's happening here? X is replaced with 2x.
The horizontal stretch of 1/2.
Good, we have to remember to take the reciprocal. Awesome. Okay, we have 2 transformations occurring in the next one. Brett, you think you could help me out with this one? What's negative 3 going to do?
It's going to be vertical stretch of 3
Yeah?
reflected over the x.
Awesome. Y is going to change its value, so we're reflecting over the x-axis. Good. And then last one we have, our x is replaced with negative 3x. So let's just talk about the stretch factor to start. Emily, can you help me out with this one? Okay, we have a reflection over the y-axis. Perfect. And a horizontal stretch of the reciprocal 1/3. Perfect. Unit 2 went well then. Okay, of the examples above, can you guys tell me which would affect or impact the amplitude? Just as a reminder, the amplitude is equal to your max minus your min over 2. Excellent. So your vertical stretch would affect those y coordinates. So it would affect the max and the min. So that would be graph 1, because we have a vertical stretch, and graph 3, because we have a vertical stretch. Okay, so when we have a vertical stretch, the amplitude will be affected. Part C, in which of the graphs above changed the period from the original graph y equals sine x? So normally, sine, if I just go over here, has a period of 2 pi. Which would impact that period? In other words, compress it or stretch it wider. Anything that has a horizontal stretch. So that's graph 2 and graph 4. So anything stretching vertically is going to impact the amplitude, and if we're stretching horizontally, that's going to impact the period. Okay? So let's just take a look at a few more equations and see what happens to the amplitude and the period. Let's just start with the base equation y equals sine x. What was the amplitude that we graphed over here? 1. Perfect. Okay, and what's the period? 2 pi. I'm just going to use 360. Okay, if you want, you can put it in pi as well. Maybe I'll put that on the side. I'll do degrees and radians. Okay, now let's compare it to the next graph. We have a vertical stretch of 2. So all your y coordinates are going to be multiplied by 2. So where will the maximum be? Where will the minimum be? -2. So what's your amp? 2. Good. Okay, do we have any horizontal stretches? No, so the period will stay the same, 360 degrees or 2 pi. Alright, next one, we don't have a vertical stretch, so the amp is going to stay at 1, but we do have a horizontal stretch, and the stretch factor will be 1/2. Okay, so we're going to have half of 360. In other words, 180 degrees or pi. So we're taking that horizontal stretch and we're multiplying it by the period. Okay, next one, we have -3. Is your amp going to be -3 then? No, because you always go your max minus your min divided by 2. So it should always end up being positive. Okay, your vertical stretch is 3. So all the y coordinates are stretching out by 3, so your new amp will be 3. The reflection doesn't change that. And if you take a look at the graph, okay, if I reflected this, is it going to change the max and the min? No. So the amplitude will stay the same. Okay, and there's no horizontal stretch, so the period will stay exactly the same. 360 or 2 pi. Here we have a reflection over the y-axis, so that's not going to change the period at all. It's also not going to change the amplitude. And as we can see, we don't have a vertical stretch, so the amp's going to stay the same. But here we have a horizontal stretch. That's what's going to change the period, not the negative. Horizontal stretch is 1/3, so we're going to multiply our original period by 1/3. That gives us 120 degrees, and what would that be in radians? 2/3, thank you. 2/3 pi. Okay, Bruce, what would be the amp for 5 sine 4x?
5.
Perfect. Okay, and Xander, how would I calculate the period? First of all, what's the horizontal stretch?
1/4.
Good. So we have 1/4. What do I do with that 1/4? So if the period was 2 pi, and now horizontally it's compressing by 1/4. Pardon? Pi/2? Maybe. I need to do a little, yeah, it would be. Okay, because you're taking 360 divided by 4, and that's 90 degrees, which is pi/2. Excellent. Okay, next one. We have a vertical stretch of 1/3, so your amp is now 1/3. Your horizontal stretch is actually 2. Okay, it's written as a half, but the stretch factor is 2. So we're going to multiply 2 times 360. That gives me 720 degrees is my new period. Or if I put that in radians, we have 4 pi. So in general, what we're seeing is that the amplitude is given by the vertical stretch factor, A. Okay, and the period will be 360 degrees multiplied by 1/b, or we could write it as 360 degrees divided by b. Would you guys think the same effects would take place for cosine? Let's take a look. Our amplitude was 1, so if I multiplied by a vertical stretch factor, would it have the same impact as sine? Yeah, it'd stretch. Okay, and then the period is also 2 pi, so if you multiplied by a horizontal stretch factor, it would either shrink it or stretch it. So yes, part G, cosine would react very similarly. We have a little summary on the next page. We pretty much talked about it all, so if you'd like some study notes, you can refer back to this page, just start it. And I'll just summarize a few things on this note here. Okay, so for the amplitude, you can measure that by going maximum, subtract the minimum, divided by 2. The period of both the graph of sine and the graph of cosine is 360 degrees. But if we have a transformation, we need to divide by the b that is actually in that equation. So if this is 2x, we're dividing by 2. As it's the same thing as multiplying by 1 over 2, right? Would you guys agree? Multiplying by 1 over 2 is the same as going 360 divided by 2. Is that the same? Yeah. And it's important that we take the absolute value because, for example, if we had sine negative 2x, okay, the negative is just telling us that it's a reflection. So we need to take the absolute value of that b so that we're just applying that to our period, not the negative as well. Okay? So for sine and cosine, they have a period of 360 or 2 pi, but then if we have a transformation, we divide by the b measure. Okay, tan's a little bit different because we don't have an amplitude. There's no maximum and there's no minimum. And if you need a reference, just over here, and take a look at it. It's going to positive infinity and negative infinity. So there's no amplitude. But the period is just a little bit shorter. It's only going through, I guess, a cycle of pi, 180. So we would take 180 degrees and divide it by the horizontal stretch factor, b. Sound good? There are a few important hints. Maybe we'll just read through them. So when you're graphing a trig function manually, first you want to draw the basic graph. So for example, sine or cosine. Then what you're going to do is adjust the basic graph for any change in the amplitude. So if there's a vertical stretch, instead of it being at 1, if it's a stretch factor of 4, where's now the maximum? 4. Okay, so 1 times 4 is 4. And then you also want to adjust the new graph for any changes in the period by dividing that period into 4 parts using the maximum and the minimum points as well as your x and your y intercepts. So let's take a look here. Okay, we have a max, a min, and we have some key x-intercepts. You can break it up into sections just to help you graph it a little bit more. What it's talking about with the period, say if you have a horizontal stretch factor of a half, okay, instead of it being 2 pi long, we'd now be at pi. So it would be condensed. Let's see what that looks like. So we have the graph of y equals 4 cosine 2x, and our domain is between 0 and 2 pi. Just looking at the equation alone, who can help me out with the amp? Okay, good. The a value is your amp. Okay, and then period, we're going to calculate by going 2 pi divided by the absolute value of our b, which is 2. So when we divide that through, we're left with pi. So the period has been shrunk by a half. So let's just start. Our amplitude is now at 4. So I'm just going to block off a 4 and negative 4. And instead of ending at 2 pi, we've now condensed, we're ending at pi. So maybe it's not an asymptote that I just drew, I'm just making boxes. Okay, little zones. So the graph of cosine, it starts along the y-axis at 1. Okay, but now we have a vertical stretch. So if it normally started at 1 and we had a vertical stretch of 4, where is it now? It's up at 4. Okay, so that's our starting point, up at 4. Okay, originally the period ended at 2 pi, but we shrunk it. It's now ending at pi. So the end point will be at pi. I'm just going to refer over to the graph here. Originally we had x-intercepts at pi over 2 and 3 pi over 2. What was the stretch factor? If you take a look at the equation, what does this 2 tell us? What stretch, horizontal stretch do we have? 1/2. So we're going to take the x-intercepts and multiply them by 1/2 or divide by 2. So, wrong graph. This one will now be at pi over 4. Okay, so we're dividing by 2. And this one will be at 3 pi over 4. So if you want to make a little note, the x-intercepts are pi over 2 divided by 2 and 3 pi over 2 divided by 2. So we're just stretching them by 1/2. So our new x-intercepts will be at pi over 4, which is 45 degrees. Okay, and then 3 pi over 4, which is 135. Okay, now that we have some key points mapped out, before we can draw these x-intercepts, we have to figure out our scale. So in between 0 and pi, how many spaces do you guys count? 6. So we're going to go 180 degrees divided by 6. Each little space is 30 degrees. Okay, so here we have 30 degrees, 60 degrees. Our first x-intercept will be smack in the middle at 45 degrees. If you want, you can label that as pi over 4. Our next x-intercept will be at 3 pi over 4, or 135 degrees. So let's just count again. We have 30, 60, 90, 120, 150, 135 will be right in between those two lines. Okay, right before 150. Okay, there's one more key point that I need to map out. And what is that? I have my 2 maximums, I have my 2 x-intercepts. What am I? The minimum, very good. So let's look at where our old minimum was. It was at pi, or 180 degrees. If we have a horizontal stretch of 1/2, what's half of 180? 90. Good. So let's figure out where 90 degrees is. We have 30, 60, 90, there we go, and that's down at -4. So all of the old critical points from the original graph of y equals cosine x, they're compressed by 1/2 and vertically stretched by 4. Okay, so now that we've mapped up our points, we can just draw a line through them. And we've got our first period of the graph. Now remind me, what is the period? We found it to be pi. Okay, and it only goes to pi. So if I wanted to draw another rotation, what I would have to do is just take the points that I have on my graph and move them over by pi degree, or pi radians. So let's take a look. If this is at 45, where will my next x-intercept be? What's the period? 180, so it's going to be 180 later. Okay, and then this x-intercept will be 180 later. Maybe I'll start with this here. This is the start. Okay, it's going to go through a wave, and it's going to end at 2 pi. That's my ending point. Okay, right now I have the minimum is at pi over 2. Where will my next minimum be?
3 pi over 2.
How'd you get that?
I added pi.
Yay, you added pi. So, or in other words, added the period. Okay, so to get to the next minimum, I have to add the period, which would be at 3 pi over 2, or 270 degrees. So here we're at 180, okay, 210, 240, 270. There's my next minimum. Another little trick too is we can pretend this is like the 0 line again. And if I'm going to find my 45 degrees, okay, there's 30, 60, 45 is right in between. Okay, and then my next one was at 135, so if I'm pretending this is the 0, then I can go 30, 60, 90, 120, 135, right in between. And I can now connect the dots, that's my next cycle. So to draw a trig function, you want to first figure out what is your amp, what is your period, what are your key points, so your maximums, your minimums, and your x-intercepts. And then you apply the stretch factors to those, okay?
Junior class change.
So the next set of questions we don't have to graph, it's a little less time consuming. We just have to figure out what is the equation. And we're going to be given the amplitude and the period. So the first function is a sine function. It has an amp of 2/3 and a period of pi/6. So we're comparing to y equals sine x. If we have an amplitude of 2/3, that's going to be your a value. So you have y equals 2/3 times sine. And just keep in mind this is the period, it's not your b value. So we need to solve for your b value. I'm just going to remind you guys of the formula we came up with before. For sine, your period equals 360 degrees. I'm actually going to use radians. 2 pi over your b value. But this time they're giving us the period and we need to solve for our b value. So can we not just switch places? So b will equal 2 pi divided by the period given. In this case, we have our b will equal 2 pi over the period, which was pi/6. So when you divide that through, you get b equals 12. So if b equals 12, we put that directly into the equation. Okay, don't worry about reciprocals or anything. Whatever you get for b is b, that goes into your equation. Okay, next function is a cosine function. So we're comparing to y equals cosine x. We have an amplitude of 3 and a period of 720. So y will equal 3 cosine, and I just have to figure out what is that b value. Okay, just a reminder, b will equal, this time we're in degree mode, so 360 divided by the period given, 720, so we get a half. And that's going to go directly into the equation. We have half of x. If you guys looked at that equation, would it make sense? Okay, we have half in the equation, so the actual stretch factor is 2. 360 times 2 is 720. So when you apply your knowledge from the transformations unit, those numbers should make sense. Okay, lastly, we have a tangent function having a period of a half. How come they didn't tell us the amp? Good. The tangent graph doesn't have a max or min. There's no amplitude. So we're going to compare to y equals 10x. And let's first just figure out our b value. Actually, I'm going to start fresh. Okay, for tan, the period is equal to 180 divided by b. Okay, because the period is only 180 degrees. Whereas cosine and sine has a period of 2 pi. So our calculation is slightly different. So rearranging for b, we have pi over our period. No there. Okay, which would be pi over 2. And that equals 2. So having solved for our b value, we can now write our new equation. Y will equal tan 2x. How are you guys finding those so far? This is the part you're going to have to memorize. It's not on your formula sheet, so you're going to have to memorize that for sine and cosine. The period is 2 pi over b, and for tan, the period is pi over b. Okay, you'll have to memorize those. So this time we're given a graph, and we have to figure out what is the amp and the period from that graph. And then from there we're going to determine the equation. So just by looking at it, actually let's talk through it first. Okay, what's your maximum? 3. It's up at 3, and your minimum's at -3. So your amplitude would be? 3. Good. Okay, what's your period?
2.
Just 2?
Or just pi, sorry.
Pi?
Pi, I think, yeah.
Okay. First of all, what kind of graph is this?
Sin.
How'd you know that?
That starts at the origin.
Good, it started at the origin. So to go through a full cycle, we have to go up, back through the x-axis, and return. Okay, that's one cycle of sine. And if we count, this is going by scale of 90, 180, 270. So it's increasing by 90 degrees. So one period would be pi. Okay? And another hint how we know it's sine. If you read the question, sometimes it can give you hints. Determine the equation of the sine function. So if you're ever unsure, sometimes it gives it away for you. Okay? But you have to memorize sine goes through the origin. Cosine starts 1 up. Okay? So they look very similar, and as we're getting into transformations, you have to be able to determine which is which. Alright, so let's write the equation now. We have y equals our amp, which is 3, times sine. And now, do we know our b value? Not quite yet. We gotta solve for that. That's going to be equal to 2 pi over our period. And the period that we found was pi. So we get 2. So I think when you said 2 before,
Yeah,
you're referring to the b value.
Yeah.
Yeah, you're a step ahead, that's alright. So we're going to throw 2x in the brackets here. Good, now a little application. Alright, so we're given a graph that represents basically a wave. Okay, so the graph represents the effect on tides on mean sea level over a 24-hour period. The graph has an equation of h of t equals a times cosine bt. T is time in hours, h is the height in meters relative to the mean sea level. We have to figure out what the equation of this graph is. So, great, they gave us an application. You can visualize it, but what you really care about is what's on the graph. Now, I'm going to let you guys try this, and I just want to see if there's a mistake that I'm predicting will probably happen. But I want you guys to just try and figure out the equation for this, and then we'll see if you guys make it or not. Don't worry, I'll help you out if you do. I thought you were like, yeah, sure. You can do it, Bertie. If you think your day's going bad, this might make you feel better. I've got a nail in my tire. So, your day might not be that bad. Luckily, it's a slow leak, so I can tell that. Jane, it wasn't you, was it? No. That's good. You don't pack nails in your pockets. How are you doing? First of all, so how are you going to figure out the age? Yeah, it's 4. So you've already figured it out. Now we need to figure out the age. Where we can find it. We need to know what is the period. What's the cycle of cosine? Does it start halfway or up?
Halfway. Oh, sorry. Or, sorry.
So let's go through one cycle. Started here. Back here.
Oh, okay.
Period.
It's at 120,
I meant that.
so, and the normal period is 2 hours.
Wait, so where does it say 120?
Well, they said 12, so it's like 100.
What is it? 4?
Here's what the scale is on, so it's like 120.
Oh, just give me a
Isn't it 12 hours? Isn't it half? Yeah, 24 hours. Isn't it half 24 hours?
Yeah. How did you get 24? Where'd you get that? So that's the common mistake. So people will read 24-hour period, which is a time span, but on the graph, what is 1 period? Okay, it's a graph of cosine. So where is it going to start? Up here. And then it's going to go down. Well, what's a regular? It's 2 pi. The period for a cosine is regular 2 pi. So it'd be 2 pi divided. And then we need the 24 after. No, 24 is not part of it. Then what's the age? Oh, sorry. This is just graphed for 24 hours. Okay, if it was 48 hours, it would just be T is amount of time, but we're not solving for T. T is going to be in the equation. It's like an answer. So he was proud of 6. You're excited about that?
I was just asking.
Just to make sure.
Did you make the mistake?
You got it, Joe.
Yeah, I cannot.
How did you? Well, you guys got the period correct, but then you have to go 2 pi divided by 12.
You still go, oh, it's 2 pi.
B is equal to 2 pi divided by 12.
Oh, I thought it was like a graph on it.
What do you mean?
We thought it was like.
Okay, but you, similar to what we did like on your test, right? Like one period is just one cycle of it.
Yeah.
Whereas the graph you drew on your test was like many cycles. The period is always one cycle. So the 24-hour period is a time span, but it's their
And then we get to go 12 times.
Yeah. T is instead of an X, it's a T.
I went too far.
All right, let's go through this. So taking a look at the graph, we need to first figure out what is our amplitude, what's our A. Okay, well the maximum's at 4, the minimum's at -4, so halfway between, it's a distance of 4. So right away we have h of t equals 4 cosine something times t. So we've got to figure out what is that b value. Just keep in mind, b for cosine and sine will equal 2 pi divided by your period. If you look at the graph, you will see that the period is 12. If you look at the text, you're probably going to get it wrong and think it's 24. This is showing for a time span of 24 hours, but the actual period, we have to start up, move down, and back to our starting position. That is one cycle, and that ended at 12. Okay, so our period is 12. And that means that our b value is pi over 6. So we can sub that into the equation, and that's the cosine function. Okay, do you guys have any questions at all?